For this problem, I'll start by treating it as a homogeneous differential equation. We'll have y double prime plus y is equal to 0. So the auxiliary equation will be m squared plus 1 is equal to 0. M squared will be equal to negative 1. We can now take the square root of both sides. We'll find that m is equal to plus or minus the square root of negative 1, or that m is equal to plus or minus I times the square root of 1. So m is going to be equal to 0 plus or minus 1 times I. So the complementary solution, yc, is going to be e to the 0x, this comes from the real part of the root, times c1 times cosine of 1 times x, this comes from the imaginary part of the root, plus c2 times sine of 1x, this also comes from the imaginary part of the root. E to the 0 is 1, so yc is going to be equal to c1 times cosine x plus c2 times sine of x. Now that we have the complementary solution, we need to find the particular solution. G of x was given as 2 times x times sine of x. Now there's two things going on here. This first is this x. If you remember, whenever we have an x term, we also have to account for the possibility of a constant. So this will be ax plus b. The second thing going on is this sine x term. If you remember, whenever we have sine x, we also have to account for cosine x. We'll get a times cosine x plus b times sine of x. We have to combine both of these to a yp. So yp will be equal to a times x plus b times cosine x plus, and we have to use some different coefficient variables. I'll use dx plus e times sine of x. However, when we distribute these terms, we'll have a b times cosine x and an e times sine x, but we already have in our complementary solution some constant times cosine x and some constant times sine x, so we have to fix this. To fix this, all we have to do is multiply both of these with an additional x, so yp will be equal to a times x squared plus b times x times cosine x plus d times x squared plus e times x times sine of x. Now that we have yp, we can differentiate. Yp prime is going to be equal to, for this first term, we have to use product rule. I'll start by differentiating the cosine x, and I'll leave this ax squared plus bx term alone. We'll get negative times ax squared plus bx times sine x. The second term of the product rule, I'll differentiate the ax squared plus bx term and leave the cosine x term alone. We'll get 2ax plus b times cosine x. For the second term in yp, I'll have to use the product rule again. I'll use it the same as I did before. We'll get dx squared plus ex times cosine x plus 2 times dx plus e times sine x. Now I have to take the derivative again. Yp double prime will be equal to, for this first term, we'll use the product rule again. We'll get negative ax squared plus bx times cosine x minus 2ax plus b times sine x. For the second term, I'll use the product rule again. We'll get minus 2ax plus b times sine x plus 2 times a times cosine x. For this next term, I'll use product rule again. We'll get minus dx squared plus ex times sine x plus 2 times dx plus e times cosine x. And for this last term, I'll use the product rule again of plus 2 dx plus e times cosine x plus 2d times sine x. We can combine some of these terms. We can combine these negative 2ax plus b times sine x terms, as well as these positive 2dx plus e times cosine x terms. So yp double prime will be equal to negative ax squared plus bx times cosine x minus 2ax plus b times sine x plus 2a times cosine x minus dx squared plus ex times sine x plus 2 times 2 dx plus e times cosine x plus 2d times sine x. The original differential equation was y double prime plus y is equal to 2 times x times sine x. Because yp is the solution to this differential equation, we can plug in yp and yp double prime into this differential equation. We'll get negative ax squared plus bx times cosine x minus 2 times 2ax plus b times sine x plus 2a times cosine x minus dx squared plus ex times sine x plus 2 times 2 dx plus e times cosine x plus 2d times sine x plus ax squared plus bx times cosine x plus dx squared plus ex times sine x. That'll all be equal to 2x times sine x. Some of these terms will cancel. We have this negative ax squared plus bx times cosine x term, and this positive ax squared plus bx times cosine x term. They will cancel. We also have this negative dx squared plus ex times sine x term, and this positive dx squared plus ex times sine x term. Those will cancel. We'll be left with negative 2 times 2ax plus b times sine x plus 2a cosine x plus 2 times 2 dx plus e times cosine x plus 2d times sine x is equal to 2x times sine x. We can distribute these two terms. We'll get negative 4ax sine x minus 2b times sine x plus 2a times cosine x plus 4 dx times cosine x plus 2e times cosine x plus 2d times sine x is all equal to 2x times sine x. We can now compare coefficients. I'll compare the coefficients of x sine x. On the left, we have a negative 4a times x sine x. We'll have a negative 4a. There are no other terms with x sine x on the left, and on the right, it's just 2. So a is going to be equal to negative 1/2. We'll compare coefficients for x cosine x. We have a 4d on the left and nothing on the right, so d is going to be equal to 0. We'll compare coefficients for sine x. We have a negative 2b and a positive 2d on the left. That's equal to a 0 on the right. So 2b is equal to 2d. So b is equal to d. Because d was 0, b is also going to be equal to 0. Lastly, I'll compare the coefficients of cosine x. We have a 2a plus a 2e on the left. That's equal to a 0 on the right. So 2e is equal to negative 2a. These 2's cancel. So e is equal to negative a. A was negative 1/2, so e is going to be positive 1/2. Now that we have all our coefficients, I'll write yp again. Yp was equal to a times x squared plus b times x times cosine x plus d times x squared plus e times x times sine x. B was 0, so the bx term will cancel. D was 0, so this dx squared term will cancel. We'll be left with ax squared times cosine x plus ex times sine x. So yp is going to be equal to a was negative 1/2, so I'll have negative 1/2 times x squared times cosine x. E was positive 1/2, so we'll have plus 1/2 times x times sine x. Now that we have yp, we can use it to form the general solution. So the general solution y is given as yc plus yp. So y is going to be equal to yc was c1 times cosine x plus c2 times sine of x, and yp was minus 1/2 times x squared times cosine x plus 1/2 times x times sine x. So that is our final answer. If this video helped you, consider subscribing.